I am going to consider a semi-transparent object. Okay, understand. What do you mean by semi-transparent object? The object which is not completely opaque and not completely transparent. Are you following it? That is known as a semi-transparent object. Okay. So this is a semi-transparent object. Okay. I hope you know the difference between what is an opaque object and what is a transparent object. Okay. So this object is kept in sunlight. Okay. So sunlight consists of millions and trillions of light rays. Are you following it? So what I am going to consider, I am considering only one ray. Okay. See, this ray I am naming for the namesake as I. Okay. So I is a light ray. Okay. So there are at least three possibilities that this ray will undergo. What are these three possibilities? We are going to see. So when this ray of light will hit the surface of semi-transparent object, what is this object? I am naming its name semi-transparent. What do you mean by semi-transparent? It is not completely transparent, not completely opaque. Are you following it? So part of this, after hitting, at the instant of, this is the point where the light ray will hit the surface of the object. So the part of this eye will be bounced back in a direction of the source. Okay, in the random direction it will bounce back in this plane itself. Understand this, it will bounce back in the surface opposite to the plane itself. Okay, I am writing this IR. This is known as reflection. Understand, I am not going into reflection directly. Okay, the part of this ray will be bounced back in the same plane, that is known as reflected ray. The part of this ray will be absorbed, so I am writing this IA, absorbed by the surface, and the part will be the part of this ray will be transmitted. It will go through this object. I am writing this IT. Okay, are you following it? So you know that light is a form of energy. Okay, light is what? Is a form of energy. At any instant, if it hits the body, which body it is? Semi-transparent. Understand this. Okay, I am not telling you about the nature of the body. It's a semi-transparent body. Part of which will be bounced back. Understand the term, bouncing back in the same plane. Okay, bouncing back in the same plane. Understand this, guys. Very, very important. What we are doing, we are developing the definition of reflection. Bouncing back of ray in the same plane is known as reflection. So this is the part reflection. Some part will be absorbed by the body. The light energy, see, light is a form of energy. If you absorb, means what? If you store if you try to absorb energy, what this light energy will be converted into heat, right? For example, if you keep any object in sunlight, what will happen? It will turn into heat. Are you following it? So the light which is absorbed will turn into heat energy, and part of it will be transmitted. Are you following it? So for the time being, you have no relation between absorption and transmission. What the interesting topic which is interesting is, we are interested in, is reflection. So have you understood how reflection is generated? Okay, reflection is a part. Okay, reflection is a part of incident ray. Understand this. Reflection is a part of incident ray. Okay, where incident ray has three possibilities: part of which is reflected, part of which is absorbed, and part of which is transmitted through the object. Okay, and what you are going to learn is just a part of the incident ray. Are you following it? So how the definition takes place? What is the definition of reflection? The bouncing back of the ray, okay, in the same plane. See, this is going in the same plane. We cannot call this as reflection. Why? Because it's going in other plane. So you can call this as reflected ray. Why? Because it is bouncing back from the surface. Which kind of surface it is? Semi-transparent. Okay, so understand, reflection is the surface phenomena. Okay, it depends on the nature of the surface. If the surface is fully transparent, there will be absolutely no reflection. There will be fully transmission and little bit of absorption. Okay, getting it? If the surface is opaque, then we will have only reflection and absorption. There will be no transmission. Your body is opaque, right? Your body is opaque. If someone lights a torch on you, do you see your skeleton? Absolutely not. Why? Your body is opaque. Are you following it? So I hope you understood from where reflection comes from. Now we will define reflection. So there is a very primitive definition in your textbook. What do you mean by reflection? Bouncing back of ray, or bouncing back bouncing back of rays, bouncing back of rays in the same plane, in the same plane. Understand this. Why same plane? Because it's a two-dimensional phenomenon. But reflection is a two-dimensional phenomena. It's dependent on the nature of the surface. Bouncing back of the rays in the same plane is known as reflection. This is very primitive definition, right, guys? This is very primitive definition. We will go and elaborate more as the lecture moves ahead. And it's a surface phenomena. You can write this in bracket. It's a surface phenomena. What do you mean by surface phenomena? Means what? It depends on the nature of the surface. Understand this. What it does, it depends on the nature of the surface. Okay. Now we will understand one by one with a great example. Okay. For example, what do you mean by surface phenomena? If the surface is smooth, or you can say regular, or you can say uniform. Okay. If the surface is smooth, regular or uniform, you will get a regular reflection. What do you mean by regular reflection? Which follows the laws of reflection. We will be dealing with the laws of reflection ahead. Don't worry about that. Okay. Getting it? There are two types of reflection. One is regular and one is irregular. So what is regular, what is irregular, that we will see. Okay. For example, this is your school. If your school is at say 7:30 a.m. right? 7:30 a.m. Your school. This is your school timing. For example, if you get up at say 7:05 a.m. Okay, if you get up at 7:05, what you will do? Will you bath? No. At that time, no bathing, right? No bath. Okay, you will have absolutely no bath, and what you will do? You just pour some water on your face, and you will run towards the school. Okay, getting it? Now the main situation will begin. So this is you. You know you had no bath, but your friends will still figure it out. अरे यार ये तो आज नहा के नहीं आए, right? Are you following? अरे ये तो आज नहा के नहीं आए. How by only one glance, how your friends are able to figure out that you did not have bath? Okay, have you wondered any time, right? Are you following it? Guys, we are not diverting from the concept. This is related to reflection itself. Okay, getting it? So in one glance, your friends will figure it out that you didn't have your bath. Okay, how much your deodorant? What you will do? You'll pour deodorant on your body. Okay, you'll have some water on your face, but still your friends will figure it out that you have skipped your bath. Are you following it? Okay, on one nice day, for example, it is your birthday. Okay. What you will do? You will put face wash. You will scrub your face, right? What you will do? You scrub your face. You will put face wash, है ना? You will put moisturizer. You will put a fairness cream, and you will go to school. So what is the comment from your friend? अरे ये तो आज नहा के आए. Means what? Your face is what? Your face is glowing. What's happening? Your face is glowing. Why? Because you treated the surface of your face. What you are doing? You scrubbed your face washed, moisturizer लगाया है ना, fairness cream लगाया है, right? Are you following it? So this will lead to a situation, that is what you mean by regular reflection. Regular reflection. So to have regular reflection, what are the requirements? The requirements is a smooth or regular or uniform surface. Okay, getting it? For example, if you apply scrubbers, if you scrub your face, if you apply face wash, so what you are trying to do? You're making the surface of your face smooth, regular and uniform. Okay, are you following it? Means if light rays, for example, this is your face. Okay, this is your surface of your face. So if light rays are hitting you, what the light rays will do? The light rays will reflect in a regular manner. What is regular, what is irregular, I will tell you. But for the time being, understand. The light rays will reflect in regular manner, which will result in a glow, or you can say in simple words, shine. Are you following it? Okay. If you go to the washing center, if you go to the washing center, what they try to do? They try to scrub with the surface of the car. Okay, before, after the car is out from the washing center, what it does? it is glows, it shines very much. Why? Because they have performed some processes towards the surface. They scrub the surface, they brush the surface, right? Are you following it? So the glow and shine ray is more when the surface is smooth, regular or uniform. Okay, getting it? Are you following it? And when we have irregular reflection, understand when do you have irregular reflection? Irregular reflection, when the surface is irregular. What do you mean by irregular? I just with an example. Or non-uniform. Okay, so when the surface is irregular or non-uniform, then we have irregular reflection. For example, I'll give you a very best example again. You get up at 7:15, the school is at 7:30, you will not have any kind of bath, so your face will have some irregularities like this. Okay, getting it? So when the light rays are hitting your surface, there is irregular reflection. The rays are traveling in the random direction. Okay, means what? Whenever the surface is irregular, what will happen? The surface is non-uniform. Surface is non-uniform, irregular reflection takes place, which results in no shine, and which results in, or you can say, dullness. Very best example, very best word to pronounce, dullness. So what will happen? There will be an irregular reflection, there will be no shine, and there will be dullness. Okay, it will resemble the dullness. Okay, getting it? So that's why your friends quickly recognize with the one glance that you have not had a bath today. Okay, why? Because see, if this is your surface of your face, it is irregular. Okay, to make it regular, what you try to do, you try to abolish this irregularities. Means what? You try face wash, you try scrub. There are many more processes, you know better than me. Okay, there are many more creams. And if you apply this cream, then what your face will look like? Your face will be abolished with this irregularity, and the surface will be smooth. Okay, getting it? So what conclusion can you derive? Reflection is regular and irregular on which terms? On the terms, it depends only and only upon the nature of the surface. Nature of surface. Are you following it? If the surface is smooth, you have regular reflection. If the surface is irregular or non-uniform, you have irregular reflection. Are you following it? But each and everything is based on what? Surface. Are you following it? So reflection is a two-dimensional phenomena, and you can also know it's a surface-based phenomena. The nature of surface determines the amount of reflection. Are you following it? So this is the basic concept, which is far more easier to digest. Okay. So as I told you, regular reflection, irregular reflection. Okay, regular reflection will follow laws of reflection, where irregular reflection will not follow. So what are those laws? Okay, laws of reflection. Okay, so if you study laws of reflection, then you will understand why reflection is known as two-dimensional phenomenon. Okay, so what is the first law? That the angle of incidence is equal to, or you can say angle I is equal to angle of reflection. Angle of incidence is equal to angle of reflection, say angle R. Okay, so theoretically we will see what is angle I and angle R. So if this is an opaque surface, what we are considering? We are considering opaque surface. To keep the simplicity of the subject, we are considering an opaque surface. Okay, say mirrors. Okay, so if this is the point of incidence, at this point itself, what we are doing? We are considering the ray is hitting. So this is known as incident ray, I. Okay, and what I will do? I will draw a normal. Okay, so guys, I hope you know what is normal and what is the tangent. Okay. So in exam, while drawing drawing a light ray, you always needs to specify the direction of light ray. See, I am specifying the direction of light ray. So this is incident ray. This will be reflected ray. Okay, R. Okay, and this is normal, N dash. What is normal? I hope you know this. Okay, if you don't know this, comment in I may take a separate lecture on tangent and normal of geometry. Don't worry about that. So, which angle you will consider? See, the angle made by the incident ray with the normal is considered. See, this is say angle I. Say if I say this theta, angle made by the reflected ray with the normal. See, guys, it's not making the angle with the tangent or with the horizontal surface. It's making the angle with the normal itself. Okay. So this theta and this theta are equal. Are you following it? Okay. Means if the angle of incidence with the normal and angle of reflection with the normal, if these both are same, then we can say that reflection is regular. Are you following it now? Means to have this surface shiny. For example, this is surface OO dash. Okay, if this is a surface OO dash, if I need to make this surface shiny, what I need to do? What is the requirement? The requirement is that whatever the rays or whatever the rays which are fallen. See, we are considering only this point n dash. There are millions of points. Okay, there are millions and trillions of points, right? So each and every point will receive the ray of light. Okay, so when this incident angle with the normal and reflected angle with the normal are same, at that point what we can say, we have regular reflection. Means what? OO dash will have a glow or a shine. Are you following it? Okay, so this is the physical significance of first law. Okay, don't just mug up the laws, try to derive the conclusions from the laws. Are you following it? Okay, so I hope you understood. This was the first law, right? What is the second law? The second law states that, see, this is very important. Second law is very important. From the second law we can say that reflection is a two-dimensional phenomenon. The normal, right, incident ray and reflected ray lies in the same plane. Understand this, very very important. The normal incident ray and reflected ray lies in the same plane. Understand, same plane. As I told you earlier, reflection means what? Bouncing back of rays in the same plane. Means what? Reflection is a two-dimensional phenomena. What do you mean by two-dimensional phenomena? The rays will travel back to the plane where the source is placed. Okay, rays will travel back where the source is placed. I will give a very best example. Okay, for example, say this is a surface, opaque surface again. Okay, this is a bulb. I can see I will draw a torch over here. Okay, so this is a torch. Okay, so millions of rays are emitted by this. Okay, so this is a normal. I can draw a normal like this. Okay, and if I consider an oblique ray like this, okay, if I consider an oblique ray like this over here, okay, making an angle theta, okay, and reflected ray here, angle is say R and here I, incident ray, reflected ray. Okay, so incident ray, say angle I is equal to angle R, it's following what? Angle I is equal to angle, it's following the first law. Okay, so all this lie in the same plane. Okay, now what I told you, the reflected ray will always lie in the plane of source. So here is the source of light, it's in this plane. Where is the reflected ray? The reflected ray is also in the same plane. Are you following it? The reflected ray will be never found in the other plane. The reflected ray will be only found where the source is placed. See, here source is placed. Are you following it? If here the source is placed, the reflected ray will be found in the same plane. Understand this. This is very important in case of numericals. Okay, are you following it? Okay, so this normal, see, this is the normal n dash, incident ray and reflected ray are in the same plane. See, everything is here in the left hand side of the object. Nothing is there over here. Okay, why? Because reflection means what? Bouncing back. You need to come back in the same plane. Are you following it? See, this is the plane of the source. So the ray will come back in the same plane. So this is the base of the second law. Okay, getting it? But now in each and every textbook you have only two laws. That's fine. But there is another confusion that when what will happen if the ray incident ray is absolutely perpendicular to the point. For example, this is point O, this is a normal, okay, this is your normal. If the incident ray is following the path of the normal itself, okay, it's making with how much angle? 90-degree angle. Okay, so angle I must be equal to angle R, means what? Angle R should be also equal to 90-degree. So the reflected ray and incident ray will be following the same path, means what? There will be no deviation. Okay, understand? So this is what can say, and some extra information for you. If the incident ray is following the path of normal, it will travel back and it will be reflected back in the same deviation. So here also, see, reflected ray is traveling back in the same plane. Are you following it? So understand, this is what you can say, this is another way to describe the ray which is following a path of normal itself. Okay, and both of them, normal, incident ray, reflected ray, are in the same. Okay, so guys, these were the definitions or very basic primitive concepts of reflection. Okay, there are much more concepts of reflection, such as say for visible light, there are much more concepts of reflection. Say the color of board is say white. Why only human eye is able to capture capture the Vibgyor colors. So these all concepts are there when you will study refraction. Okay. So these were the concepts of reflection, very much necessary to understand the concept of refraction, diffraction, interference. Okay, getting it? So I hope you understood each and every concept. If you have any doubt in the lecture, you can comment in the comment box. Okay, have a nice day.